pressure to leak out once it exceeds a very, very high temperature and pressure. And that's a fail-safe. You know, be very careful on that. I hate to talk about things I've seen in the field because someone didn't understand the purpose of that type of relief plug. A lot of those things will have a threaded outlet on it so that the refrigerant can be piped to a safe place. I've actually come upon a system before that someone had put a cap on that where the lead was leaking, and they didn't understand what it was and actually put a cap on it. They defeated the final safety entirely by doing that. Hope you don't run across something like that, but if you do, be aware it's not supposed to ever be capped. Okay. All right. You also have what's called a suction line accumulator, and I've drawn that behind here. A suction line accumulator, and also I've drawn a receiver. Physically, they look about the same, but they're entirely two different components. The suction line accumulator allows the refrigerant, if you have excessive liquid coming back towards the compressor, it allows it to go into a tank. That tank will has a little U-tube coming back in here to the outlet so that it doesn't pick that refrigerant straight up. But keep in mind there is a small drill hole in the bottom of this U-tube so that you can pick up the oil, because the oil is not going to vaporize. The refrigerant, the vapor, as it vaporizes, will come back into the top of the U-tube and back to the compressor. But it does have a small hole to pick up any oil that may be lodged in this particular accumulator. Accumulator is like having insurance. It helps prevent liquid getting back to the compressor. It won't stop it entirely, but it helps prevent it. It gives you that little bit of insurance, if you will. Whereas a receiver is actually a storage tank for excessive refrigerant. You'll see a receiver is used where the load may change, refrigeration in particular, where you may have load changes, and the TXV or the metering device may actually have to feed more refrigerant at times than it would under normal conditions. You'll also see a receiver used where you have a ambient control system, and we'll talk a little more about that, like I said, in just a little bit. A few other things that you're going to see out there is sight glasses. You can see this particular sight glass has an indicator in it to tell the condition of the refrigerant and whether or not there may be moisture in the system. It has, I want to pass that around. Plus, you can see the refrigerant, what state it's in. Here's another sight glass. This one does not have an indicator for moisture. And pass that one around. One thing I hear people say that kind of bugs me, you know how sometimes a phrase or something just kind of gets on your nerves. Y'all probably not like it. But when I hear somebody say, hey, this sight glass has got air in it, I panic. I hope it's not air in the system. It's vapor. Okay. Normally a sight glass on a liquid line is going to look solid. It's not going to have any bubbles in it, but definitely don't want to have air in the system. Okay. It's just one of those terminologies that sometimes we have a tendency to say, and I panic though when I hear somebody say it's got air in it. You know, I'm thinking, oh no. All right. You didn't know that some refrigeration systems have a muffler, did you? Okay, there it is. Okay, a muffler helps reduce the pulses that are emitted from the compressor and helps minimize that vibration through the system. A muffler goes on the discharge line. It does not go on any other line. And just looking at that, you see this little device? This is a filter dryer. This goes on the liquid line. Normally, you'd see that on the liquid line. I say normally because there was a particular technician that just insisted on putting these on the discharge line. Why? I don't know. we've discussed it, and let's put it this way, he brought me a lot of business. Yeah. But the liquid line filter dryer does just that. It filters the liquid on the liquid line, removes any particles that may be in it, and also helps reduce the amount of moisture in the system through dust inside of it. All right. A couple of other things I got laid out here. There's a suction line to liquid line heat exchanger. You can see the big and little lines here on both sides, but that's just a heat exchanger. It helps subcool the liquid and helps superheat the suction gas going back to the compressor. Helps prevent liquid again at the same time subcooling the liquid going to the metering device. All right, we covered almost everything we need to on our show and tell here, but I want to show you a suction line filter. Do you notice the two caps here? That's for measuring the differential in pressure across here. A suction line filter is usually something that's added back to a system after you had a compressor failure. You want to catch any impurities that may be flowing back to the compressor long before it ever gets there. A lot of times these will actually have desiccants and other devices in them to help neutralize any acid that may be in the system. But if this differential pressure exceeds, I think it's 2 to 3 pounds, I have to go back and see what that is. But you want to change this out, get rid of it if it's done its job. You don't want it to be a restriction in the line. You can pass that around. You can see the difference between that and a liquid line filter, I believe. One other item that you'll see from time to time out there, this is a head pressure control, a head pressure or a system that uses water to cool the hot gas, and this throttles the amount of water that's going through the condenser. Okay? As the pressure goes up, it increases the pressure on this bellow here, which allows more water to go through the water-cooled condenser. Pressure goes down, it reduces the amount of water. Okay. There's also some things called vibration eliminators that you'll run into from time to time. They do just that. They help isolate the compressor from the rest of the system. They must be installed correctly. When I say installed correctly, if you put them opposing the vibration, you have not done it. It needs to be in parallel with the way the vibration, usually parallel to the crankshaft. Okay, we'll go in a little more detail on that a little later in our class. All right, real quick, I want to cover some of these components and where you'll see them on the system. Where's the best place to start? Compressor. Absolutely. We leave the compressor, you see the muffler. Okay, the muffler does just that. It helps take the pulses away from the rest of the system. We come on up, we see a fan cycling switch. The fan cycling switch is going to control the condenser fan according to the pressure or temperature of the condenser. Okay, do see a temperature control. Now this one has a head pressure control. What happens is we either send the hot gas by the condenser straight to the receiver or through the condenser. This is using what's called a flooded condenser for ambient control. We back the refrigerant back up into the condenser during low ambient. We notice that it all comes to a receiver, comes to the receiver to a liquid line dryer. We see our solenoid valve, moisture and liquid indicator, sight glass if you will. We see an expansion valve. We come on down, we see a temperature control here. Makes sense, we're going to control the temperature of the product or the space that we're conditioning. We come into the evaporator, we see an EPR, evaporator pressure regulator on the outlet of the evaporator. Here's our suction line filter dryer. into a, next thing we go into a suction line accumulator, and you see the compressor, low pressure and high pressure control, along with the oil safety control at this point. Notice this one also has another solenoid valve here with a hot gas bypass regulator that can induce a false load on the evaporator in times when you still want to do some dehumidification. That's what that's all about. You'll see that in some commercial air conditioning, or possibly in some cases where you have a hot gas defrost. I know that's a lot that we just covered, a whole lot. But the idea is to get out there in the field and have some understanding of what you're looking at without just saying, uh-oh, what's that? Never seen anything like that before. It's a little late to be in front of the customer and all of a sudden have to figure something out. So if you have some idea of what you may run into out there at this particular point, it helps to get yourself prepared for when you're out there in the field. Any questions? All right, we're going to sum that one up. Thank you.